So I'm William Dinsdale, and you probably came here from my Google Classroom. It is called Tech Ed, and today we're going to be learning Boolean algebra. So as you can see here, I've got a table, and what we're going to be doing is we're going to get a 1 here, a 2 here, we're going to get a 4 here, and we're going to get an 8 here. Now, tell me if you can see any patterns here. I'll give you 5 seconds. Okay, so basically, if you don't understand it, it's just doubling from 1 to 2, and then you double 1, you get 2, you double 2, you get 4, you double 4, you get 8, and you can even go further than that. You can go double 8, 16. We're just going to go 4-bit, and basically, so this line means equal to. So basically, this line means it's equal. The bottom one is equal to the top one. The bottom line that we just drew is equal to the top line that we're about to draw, and the bottom line is equal to all of them if they're off. So we can see if that's equal. So from the bottom right, we can see that 1 there, and then if we go to the top right, we're going to draw a 1, so it's equal. They're both equal. Now in this area here, you see next to the 1 there's a 2, so next to the 1 on the top, we'll put a 1 here, and that 1 is equal to a 2. Now you can see the 4 on the bottom, and that's equal to a 1, so we'll put a 1 up top, and the 8 down here is equal to a 1, so we'll put that up here. Now, considering that, if we say there's no 1, then we can see, and then we say there is a 2 in the number, and there is a 4 in the number, but there's no 8. Now it's easy to cut. Now all you need to do is just add 4 and 2 together, and you get 6. Now it's pretty easy to understand that, but if you don't, we can go over it again. So we see that we have a 1 here, 0 here, and a 1 here, and a 1 here. Now if we add 8, 4, and 1, because those 1s there in the middle layer are equal to the 0, and that 1 there, so all the 1s are equal to the ones below them, the numbers below them, and the ones on the top it's equal to 15, but 1 is equal to that, 2 is equal to that, 4 is equal to that, and 8 is equal to that 1 up top too. So what we're going to be looking at is basically, we're going to look at all of this stuff, and we're going to look at another one. I'll see you. As you can see, I've written down some functions here, and these functions are the basis of all the operations. So if you have all these, you can pretty much do anything else, and you only really need and not to do anything else, but this is just useful to do everything else. So as you can see, I've put some parentheses there. I think that's what it's called. Yeah, so I've put some parentheses there, and I've done something wrong. So I just need to go like that. Sorry about that, but here we go. I've got it all. So let's discuss each function. So first up, we're going to do or. Okay. So I want you to follow with me. Let's get or, and we will go for the OR operation, we will be using a, never mind. So, yeah, for an OR operation, we'll be using this symbol, and it's an OR symbol, and that is what we will be doing. Oh, OR. Okay, so here we go. First up, we will draw our top area. So we are going to be going OR 1, 0, 1, 1. So, just a sec. Okay, I'm back. So what we're going to do now is we're going to go to here, and we're going to go 0, 0. I'm going to 0, 1, 0, 1. Now we're just going to go like that. And then we'll go like, okay, so there we go. Now what we're going to do is we're going to go, so we're going to ask this one here and this one here. Is there one here? And is there one here? Now, if one of them says yes, or both of them, then we put a 1 here. Now, we basically just do that, so that's, and if there's no 1 there, then don't put anything there. So then following these rules, we do that. Now, if you've got that, now maybe just watch over that a couple times, and I'll be back with the next one. Okay, so we'll be discussing AND now. Now, this is the meaning of AND. So, the meaning of AND is if, say, we got a 1 and a 1, and we got 0, 1, and we got a 0, 0. Now, if both are true, which in this case is 1, then 1 is true, 0 is false. And if both are true, then the output is true. If only 1 is true and the other is false, then output false. If both of them are false, then output nothing. Okay, so using that logic, we're gonna go with a 1, 0, 1, 1, and then this function is there we go. Now, sorry if I mix up the symbols in this video, but I'll definitely check later. But here we go, and we can say that using that logic, 0, 1, 0, 0, 0, 1. See that? We all got that? Yeah. Okay then. Oops. So what we're gonna do now is we're gonna, oops. So what we're gonna do is we're going to discuss XOR now. Now just draw an X and then OR, and then you need to get a table. So if we have 1, 1, 1, 0, 1, 0, 0, 0. Okay, so the logic is exclusive OR. Now, exclusive meaning it's not on if both of them are false, but it's the output is false if both of them are false. The output is true if one of them is true and the other is false, and then we've also got the idea that if both are on, then the output's not on. So using that, we can determine that there is 0 here, 1, 1, 0. Do you get that? Yeah. Okay then, if you get that, then we have, then let me know, because, you know, it helps out. Or just in classroom, just leave a note, something just leave a note in one of the assignments. I'll see it in the review. But here we go. Let's go on to the next one. We're gonna go to, what's next? I'm pretty sure it is, and then I'm pretty sure the next one is not. Yes, not. So this is what not is. So not is when it's not the input. Now there's only one input on this, so this is what the symbol is. And we can go like this. Now all you need to do is just invert it, so you've got one input line, then the output is 0. Okay, so 0. So this is basically, it just inverts the signal from false to true, from true to false. You know, you get that? Okay, well that's it for this video, and make sure to stick around for the next classroom assignment.